Let's look at a problem from the book. We'll look at problem 8.6. What we are asked to, we are given a car with a mass of 2000 kilograms and a center of mass whose position is G. So we need to determine the towing force F required to move the car. Both the front and rear brakes are locked, so both tires are locked. Let's take a coefficient of static friction to be 0.3. There is another problem in the book which is identical, but only one of the tires is locked. So don't confuse the two. We are looking at problem 8.6. As usual, we start with the free body diagram. So here I have a nice picture for it. You don't have to draw the car when you're doing that, but so we have a total of 5 forces applied on our body. There is the external force, the towing force. Then there is the two normal reactions in A and in B. And then there are the two friction forces in A and in B. Being a two-dimensional problem, we have 3 equations. The sum of forces on X and Y being equal to 0, and the sum of moments being equal to 0. But additionally, we have 2 more equations, the equations of the static friction, because we know we need to determine the limit force in order to start moving the car. So this force has to be equal to the maximum friction force that the two tires can produce, and this maximum friction force is going to be equal, in the case of A, is going to be equal to the coefficient of static friction times NA, and equally for B is going to be the coefficient of static friction times NB. So at the end of the day, we have 5 equations. If we add these 2 to the other 3 we previously had, and we have 5 unknown, so we are able to solve this problem. Let's write down our equations. So I will remove this. I'll write the sum of forces on Y equal to 0, which is going to give me external force F component on Y, so sine of 30, plus the normal force on A, plus the normal force on B, is going to be equal to the total weight of the car, so this one, which is W. Sum of forces on X instead equal to 0, so this is going to be FA and FB which are equal to F cosine of 30. And then I have the sum of the moments. And for convenience here, I find that taking A as the position from which to express the moment is the easiest way to eliminate more possible forces. Be careful that the forces are acting at the point of contact between the tire and the asphalt, not at the axle of the tire. So, sum of the moments with respect to A gives me F cosine of 30 times 0.3, which is this distance here, minus f sine of 30, 0.75, which is instead this distance, plus nb times 2.5, so 1 plus 1.5, this distance here, minus the weight of the car times 1, and this has to be equal to 0, times 1 because this is clearly the arm for the weight with respect to A. And then additionally I have the two equations I wrote before for FA and FB. So I have this system of equations, is a linear system of equations. You can solve it any way you want. If you are lazy like me, you do it with MATLAB, or you can substitute the variables. You shouldn't have no problems in solving it. The result at the end are gonna be the following. I'll get rid of this part. You should get f equal 5.79 kilonewton, NB equal 8.11 kilonewton, and A equal 8.6, FB is equal to 2.4, and FA equal to 2.5.